this video, we're going to practice converting from grams to moles to molecules, and vice versa. If you cannot convert from grams to moles or moles to grams, please go ahead and review that first with your teacher. One important thing to keep in mind during this video is we are going to start using Avogadro's number. As previously discussed, Avogadro's number is 6.02 times 10 to the 23rd, and that can be molecules, particles, or atoms. It is important to remember when putting this number into the calculator, you should use it and put it in parentheses. Let's go ahead and do some practice problems. You're going to need a calculator, something to write with, and a periodic table. All right, we're going to practice doing some grams to moles to molecules conversions. You do need a calculator, a periodic table, and something to write with. One important thing to remember for this one is we are going to start to use Avogadro's number. Avogadro's number is 6.02 times 10 to the 23rd, and that unit could be molecules, particles, or atoms. When you put it in your calculator, you do want to put that number in parentheses because of order of operations. So let's go ahead and get started. The first one says, how many moles are in 8.3 times 10 to the 23rd molecules of water? So our given is 8.3 times 10 to the 23rd molecules. 8.3 times 10 to the 23rd molecules. Okay, if you have molecules at the top, you need molecules at the bottom. The number that always goes with molecules is Avogadro's number, so 6.02 times 10 to the 23rd, and that's equal to 1 mole. Our molecules cancel out, and then we're going to multiply. So you multiply the top and then divide by the bottom. When I put this in my calculator, I'm going to put both of these numbers in parentheses. So 8.30 times 10 to the 23rd divided by 6.02 times 10 to the 23rd, and you get 1.38 moles. Okay. Take a minute to solve. If you have any questions, please check in with your teacher. Number 2. How many atoms are in 2.5 moles of oxygen? So we're going to start with 2.5 moles of oxygen. Okay. Reminder, whatever unit you have on the top, you have to have at the bottom. So we're going to have moles of oxygen down here, and that's equal to 1. We're looking for atoms at the top. The number that goes with atoms is 6.02 times 10 to the 23rd. I'm going to put it in parentheses, and then we can solve. We're going to multiply the top, so 2.5 times 6.02 times 10 to the 23rd, and in parentheses. Anything divided by 1 is itself, so 1.51 times 10 to the 24th. Now your calculator might show 1.5 e to the 24th. That is the same thing, but you do need to write this ending. If you have any questions, make sure to check in with your teacher. Number 3. We're going to start to do 3 steps or 3 sets of railroad tracks here. We're going to go from grams to molecules, so it's going to be 3 sets of railroad tracks. We're starting with 9.34 grams of lithium, so 9.34 grams of lithium. Now if you have grams at the top, you need grams at the bottom. We already used grams from the problem, so we have to go to our periodic table to get the formula weight. Li and Cl, there's 1 of each. The mass of lithium on the periodic table is 6.94. The mass of chlorine is 35.45. And we're going to add them together. So 42.39. And we can plug that in. We know that's equal to 1 mole because the formula weight or molar mass is always equal to 1 mole. Now, if we wanted moles, we would stop there, but we want molecules, so we take it one step further. If I have moles at the top, I need moles at the bottom. So 1 mole is equal to Avogadro's number, so 6.02 times 10 to the 23rd molecules. Our moles cancel out, our grams cancel out, and then we're left with the math. 9.34 times 1 times Avogadro's number. You're going to hit enter and divide by the bottom number. So 9.34 times 6.02 times 10 to the 23rd divided by 42.39, and you get 1.33 times 10 to the 23rd molecules. Okay? This was a 2-step equation or a 3 sets of railroad tracks, so make sure you follow along, or if you need help, check in with your teacher. We have one more 3-step with railroad tracks. Our given is 3.3 times 10 to the 23rd molecules, so we're going to work backwards this time. So 3.3 times 10 to the 23rd molecules. If you have molecules at top, you need molecules at the bottom. So 6.02 times 10 to the 23rd molecules is always equal to 1 mole. If I wanted moles, I would stop there. If you have moles at the top, you need moles at the bottom. And then it's going to equal grams of N2I6. So we need to go to the periodic table to get that. So we have N and I. There's 2 N's, 6 I's. Nitrogen is 14.01. Iodine is 126.91. So this is 28.02. So 6 times 126.91, 761.46. We add them together, and we get 789.48. So 789.48. Our moles cancel, our molecules cancel. You're going to multiply the top, making sure everything goes in parentheses if it has an exponent, and then divide by the bottom. So 3.3 times 10 to the 23rd times 789.48. Hit enter. Divide by, in parentheses, 6.02 times 10 to the 23rd, and you get 432.77 grams of N2I6. Okay? If you have any questions, make sure you check in with your teacher.